Okay guys, so in the previous video I basically did some dimensional analysis and I have already kind of changed my units so that I have feet or velocities that are of matching units feet per second. So now I want to discuss some of the geometry of the problem. Fortunately, Will Smith is a great sharpshooter and he was able to scout a location which is parallel to the train, and he obtained his angle. He located the target at 11 o'clock, which is 60 degrees from his horizontal position. So he locates that target at time equals 0. Now he knows that if he shoots the bullet at 11 o'clock, he is going to miss because the train is moving already at a very fast speed. And he's also very far away. He is 3,000 feet away. So that is a lot of distance. So he's definitely going to miss. Instead, what he does in the movie is he waits 2 seconds. So he waits 2 seconds at times equals 2 seconds. He shoots. Right? So he shoots right there. Now he estimates, right? He did some of these mathematics. He basically played the whole scenario in his head, given that he's the best assassin in the world. He estimates that the bullet will reach the moving target at 1 second after he shoots. Now in total, right, so we're going to go ahead and say that at times equals 3 seconds, he kills the target. We're going to go ahead and find some of the mathematics that he did in order to prove him right. So the very first thing we want to go ahead and do is multiply the velocity that the train is moving times the 3 seconds that expired, because that is going to be the new location of the target. Okay, so we're going to go ahead and multiply 216.9 feet per second times 3 seconds, and that will give us, it will yield 216.9 times 3. This will yield 650.7 feet. I am estimating everything to the tenth of a feet. So we know that he is at 1,000 yards, and when he shoots, the train has moved 650. Let me go ahead and change the color to specify this new number that we have found, which is 650.7 feet. Okay, so let's see if his assumption that the bullet will reach the target at 1 second is correct. So one thing we could use is use this 60 degrees already, right? Since we know that his position is parallel to the train, and we also know that this line right here is going to be a transversal line. So if you have two parallel lines in a transversal, we also know that the angle right here inside this sort of triangle or geometry is going to be 60. Okay, now that is sort of a recall to geometry, so please go ahead and refer back to that material if you are unsure as to how I reached that conclusion. So notice how this time I now have, basically I have two sides, two distances, the 650.7 and also the 3,000 feet. And I'm given an angle, a central angle of the triangle at 60. And so I want to go ahead and prove that he is correct in his assumption. So I want to find this x, right? I want to find that missing side. Now, one way you could do it is by applying the law of sines or the law of cosines, right? because we're given two sides and an angle, I'm going to go ahead and apply the law of cosines. Now, the law of cosines says that I have c squared equals a squared plus b squared minus 2ab cosine of the matching angle. In our case, this is our angle right here, the 60 degrees, and our matching side is going to be the unknown. So I'm going to go ahead and replace those values. So we said that we call cx, and we know that one of the sides is 3000 squared, and the other side is going to be 650.7 squared as well, minus 2 times blah 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 blah, right? Cosine of 60. Okay, so now we're going to go ahead and find this number. So excuse me if I take a little bit of time to do that on my calculator. I didn't previously calculate it. So that's going to be 3000 squared plus 650.7 squared minus 2 it's going to be 2 times 650.7 times 3000 times the cosine of 60. Make sure that you put your calculator in degrees if you are working in degrees, and we are. So this is going to give me a huge number. We're going to call this a number. And notice how I have the squared. So in order to obtain x, I'm going to take the square root of that number. So let me go ahead and take the square root of my answer. And I'm going to get x as equal 2,730 .479 feet. Okay, so look at this. This is kind of neat. His estimation is pretty close because, right, you have the distance to be 2,733.5 and the velocity is going to be 2,730 feet per second. So it will definitely take 1 second to reach the moving target. However, he's going to be off, and for a sharpshooter, that's going to be a problem. So if you get to watch the movie, you're going to see some of the ensuing dilemma in this problem, right? But he is pretty close in his estimation. However, he is off. So let's go ahead and stop right here and then reach part C, in which I'll talk about the final solution.